Morning everyone. Welcome to the first of 6 lessons on exponentials and logarithms. There's going to be 2 parts to this one lesson and we are going to use the textbook that you should all be able to get now from the school that's sent out to you, and we're looking at chapter 13, exponentials and logarithms. Before we start, there's a very useful video clip here of how you use exponential modelling to predict various things. In this case, it is the COVID-19 virus. It's very informative, but also shows about the limitations that using such a model has in a situation like we are in at the moment. So again, it's quite useful to look through, and it gives you a flavour. So as I said, there are 6 things we're going to look at. The first of these are sketching, including transformation of graphs, looking at where the power might be a negative as well and what happens there. And then we're going to look at logarithms, the graphs, exponentials, the natural logarithm, and curves, including the relationship as written y equals kx to the n. So I'm going to ask you to draw and sketch throughout today. The difference between drawing and sketching. Drawing is more precise, more accurate. The axes are labelled, whereas sketch is more freehand. So I'd like to draw this out. I know you've got graphical calculators. I know you can use sites like Desmos, but it's good to know actually if you do know how to do it rather than press buttons and not be too reliant on technology all the time. So do sketch this, draw this one out. In order to help you, you might want to draw a little table like that with some set values, just to give you an idea of what's happening. So what I'm going to ask you to do in a second is to pause this video, draw this out, and then press play. Okay, welcome back. Hopefully this is what you would have got, and you would have noticed hopefully 3 things. Okay, the first of which is that the graph never goes below this. This is an asymptotic line. So this axis here is asymptotic. Also notice that the value goes through 0, 1, more on that later. And thirdly, it's not like a straight line where the gradient's the same all the way through. Here, it gets steeper and steeper and steeper. It gets exponentially bigger, meaning that it will get very tall very quickly. And this is growing upwards. So this is an exponential growth curve. What happens when we look at y equals 1 to the x, y equals 3 to the x, and y equals 5 to the x. So this time I'd like to sketch, so quickly draw down what you think it will look like. Be really quick, don't overthink it, don't use graphic calculators, don't use Desmos. Pause. Okay, let's see what you got. Quite interesting really. What you notice is y equals 1 to the x. It's actually a horizontal line here, as you can see. Y equals 5 to the x is our steepest one here, and then y equals 3 to the x. Again, those 3 things, they all go through 0, 1. None of them go below this line here, and the 5 is steeper than the 3, which is steeper than the 1, and interestingly enough, the 1 is flat. So anything greater than 1 is going to have a growth line. That's interesting if you think about it. So, what happens here? I'm going to use in the next 2 sketches the y equals 2 to the x. I think it's quite a useful one to model from. And in this case, we're looking at y equals 2 to the minus x, which can also be written, don't forget, as y equals a half to the x, and see what happens there. So, before you pause, just let's think about the transformation of what's happening. To give you some clues here. Here, the only difference is you've got a negative in front of the x here. What happens when you transform a shape by putting a negative in front of the x? Pause and sketch. Let's see what you did. Okay, bit dyslexic. That one is here because that is our regular one. So that is y equals 2 to the x. And this one here is an exponential decay. It's going down. Again, both asymptotic line is here, both go through 0, 1. But notice the transformation, when we have a minus in front, it's a reflection in the y-axis, isn't it? the 1's output here now takes on the -1's output, and it kind of just reflects in this axis here. Let's see what happens when we do these two transformations. Here again, we're doing a transformation inside, and here we've got that old one we've just done, plus you've got a transformation on the outside. So I wonder what's going to happen. So think about this, what happens. Pause and sketch. Okay, let's see what's happened. Well, we've got our regular 2 to the x here. Notice this time neither of the other two go through 0, 1. Rather interesting. Let's consider this red one here. Okay, so this red one here, if we look at it, we can see that actually there's been a translation to the right. This is shifted to the right. So when we put on the inside a translation of -1, it means that the whole shape moves 1 to the right. Notice now the value of 1 here when x is 1 is going to adopt as if it were 0. So it's 1 here, but it's going to take on the output value as if it were 0. So it's going to drag this curve to the right 1 unit. What would happen, I wonder, if this was +1? Well, in that case, the -1 here, so that would be -1 plus 1 is 0. So the -1 would take the 0's value and drag this one to the left 1. So that's the transformation of that curve there, and you can see there. Now this one, rather interesting. Well, two parts to this one. The first part is that it's very similar to what the -x was here. And we've seen that one in our previous example here. So that's that one there. And now let's look at the minus part there. So first of all, we reflect it in the y-axis, and then we reflect it in the x-axis. And that's why you get that graph there. Rather confusing, but there we go. And beautifully through the -1. Now let's look at an example. The cost in pounds of a widget t years after initial production is given by c equals 10 plus 20 times 2 to the minus t. Now this example is taken from the book. You can look in the book. Again, what I want you to do is pause and then have a go at doing it. Okay, let's see what you've done. I've just drawn a little table here just to help me with the sketching part. Let's see, what's the initial cost? Now obviously the initial cost is when t is 0. When t is 0, don't forget 2 to the 0, 2 to 0, anything to the 0 is going to be 1. So 20 times 1 plus 10 is 30. Notice it hits there at 30. Also notice what happens when it becomes very large. Well, let's look at the transformation here. We've got a few things going on here. That plus 10 is a shift up. So the asymptotic line that was historically down there is now at the horizontal y equals 10 or c equals 10 line here. So now that's our asymptotic line, and the curve won't go below that. Also notice it's going down, it's a decay, because that's a negative there, so it's decaying. So it starts at 30 and then tends towards, as t gets very large, 10. So what happens to the cost as t becomes very large? Well, the cost tends towards, never reaches, but tends towards 10 pounds. And there's our sketch. So, over to you now. What I want you to do is go to exercise 13.1, try a few of those questions, check your answers, then come back to me and see if you've got any problems, and I'll help you then. Hope you've enjoyed this. See you later.